In this lesson, we're going to look at isotopes. Now, you guys have been working through this, and you know when you manipulate the number of protons, you're changing the identity of an atom. When you manipulate the number of neutrons, you're not. You're just adding or removing particles from the nucleus, which has the effect of changing the mass. Now, we're going to look a little bit closer at that, and we're going to make sure we understand the terminology that goes with it. So here's a cell on a periodic table. Now, usually you'll see another number in there that is not the mass number or the atomic number. It is the atomic mass. We'll get to that later in the unit. But atomic number we know is the number of protons. Remember, protons determine the identity. It's the number of positive charges in the nucleus. It's listed on the periodic table, and they're all unique. In fact, if you look at the periodic table, you'll see that it goes 1, 2, 3, 4. It's the number of that element is actually the number of protons in that element. And because atoms are neutral, there's an equal number of protons and electrons in the neutral atom. Now, you guys are aware that an ion is charged, and we can change the number of electrons, but for a neutral atom, the protons and the electrons match. The mass number, it depends on the periodic table you have. Sometimes it's listed, but there's more than one mass number, as you guys have seen. We can have isotopes, so you might get stable or radioactive things, but the mass number is the number of protons plus the number of neutrons in an element. And because there's so many of these, periodic tables can't list them all. You got to look up in a table to see what stable or unstable isotopes might exist. Electrons are not included in the mass number. One, their mass is so small they don't affect the mass of an atom. And two, we're really talking about this definition. Mass number is protons plus neutrons. Electrons are not in the nucleus. Remember, they're in the cloud around the nucleus. And we can identify a specific isotope of an element by writing its name and then its mass number. So we could write oxygen 16, and that would tell us that we're talking about oxygen with 16 particles in the nucleus. We know from the periodic table that 8 of those are protons, so we would know this is 8 protons. That only leaves 8 things to be neutrons. Now, isotopes, like we just said, atoms with the same identity but different numbers of neutrons. So here we have 3 examples: lithium, 4, 6, and 7. All of these are lithium, and they're all lithium if you look at the periodic table because they have a 3 protons in the nucleus. They're a 3+ atom. But this one would have 1 neutron, because 3 plus 1 is 4. This one would have 3 neutrons, 3 plus 3 is 6, and this last lithium 7 would have 4 neutrons, right? Our neutrons can vary, but our protons never do. And so we know atoms of the same identity are not always identical because the number of neutrons can in fact vary. Now, what I just did is how you guys are going to do this. If you have a periodic table, this is a whole lot easier. Otherwise, you got to try to memorize all these. The reason they wrote them down is so you don't have to. Atomic number is the number of protons, and on a neutral atom, this is the number of electrons. Mass number is protons plus neutrons. And so that tells us right there, if I just want to solve these two things for the number of neutrons, I can take the neutrons is equal to the mass number, which is both of them, and subtract out the protons, which is the atomic number. So mass number minus atomic number is the number of neutrons. Protons are in the nucleus, so they will change both the identity and the mass number, but neutrons, having no charge, they don't change the identity of the atom, they just change its mass number, not its identity. And then you guys have to fill out this table at the end of the lesson, the lecture tutorial, and you need a periodic table in order to do this. Sodium, 23. This right here is the mass number, right? If you go find the periodic table, you'll see that sodium is Na. It is the 11th element. That's the atomic number. So the number of protons is 11. Now all I have to do is 23 minus 11. And that gets me 12 neutrons. And then the number of electrons has to match the number of protons because the atom is neutral. Those two columns are always going to match. So then we have atomic number 15 and mass number 32. So that tells me 32 minus 15 is 17 neutrons. Atomic number 15 tells me 15 protons, 15 electrons, because the atom is neutral. And if I grab my periodic table, I see that the element that has 15 protons is phosphorus. It's the 15th element on the table. Our symbol is P for phosphorus, and so we can write phosphorus and this is phosphorus 32 because its mass number is 32. Now right here we have the number of electrons is 20. That right away tells me the number of protons is 20. The number of neutrons is 24. I can add those together and get 44 for a mass number. Atomic number is 20 because that's what the number of protons is. So again, I go back to my periodic table and we see that the element that has 20 protons is calcium. So we can come back here and we can finalize this. We can say calcium 44, and our symbol for calcium is Ca. Now if we're giving the symbol of the isotope rather than the element, we can actually do that by writing the mass number up on the top left side. So this could be sodium 23, phosphorus 32, calcium 44. Sometimes people will also write the atomic number down below, 11, 15, 20. That is redundant because if you know it's calcium, you know it's got 20 protons.